Hi, in this video we're going to talk about feature engineering. So what do I mean by feature engineering? Remember that we talked about this notion of parsimony, that we prefer simple models when possible, but parsimony does not mean sacrificing accuracy or predictive performance in the interest of simplicity. So variables that go into the model and how they're represented are just as critical to the success of the model as other things we can think about. Feature engineering is a way that allows us to get creative with our predictors in an effort to make them more useful for our model, and more useful usually means to increase its predictive performance. So we're going to work with the same training and testing sets as before, and this is where having set a seed is going to help us from one video to the other, because we can again set the same seed and then do the initial split from our email data set to split our data into training and testing data. And for those, we're using the functions training and testing. Okay, now what do I mean by feature engineering? We said getting creative with the data. Remember that one of the variables in our data set was time, and that's actually a date timestamp for when the email was received. For example, if I look at this first email here, it was received on 2012/3/18, so March 18 at 16:47 hours and 58 seconds. Now, if we were to use this time variable directly in our model, what R will do is to convert it to a numeric string so that each of these different timestamps will be associated with a numeric string. And they will be in order, so bigger will mean later in the year. So they might in a way be helpful, but there may be other pieces of information that we might want to extract out of this variable. For example, is it possible that spam behavior is different on the weekends and weekdays? I feel like it might be. I feel like I get more of this come shop at our store 20% off type emails more on the weekend than I do on weekdays. It is also possible that month might change things. Remember that we're looking at a 4-month period starting in January in this data set. Maybe more spam email in January, right around the new year. I don't know if these are true, but we might imagine that these might be useful pieces of information and potentially more useful than just that numeric string that R would convert that date timestamp into. So a simple approach for engineering such features, so what we're doing is we're creating new variables. It's really a fancy way of saying creating new variables that might be useful for our model, would be to do it the way we know how. I want a new variable. I'm going to use the mutate function from dplyr. So I can take my training data, remember my holy testing data, I don't get to touch it. I take my training data and I say, let's mutate and create this data frame and create some new variables. I might just get the date. So instead of the date timestamp, I might just look at the date. I might also look at the weekday. So these are functions from the lubridate package. The weekday to say, so one represents, I think Sunday here one represents, and so it's a week that starts on a Sunday, and 2 represents Monday, so on and so forth. So we might take a look to see, might there be different behavior between the days of the week, and also the month. So third month here represents March, for example. And so we might do it this way. And in order to show you the results, what I've done is I've created these 3 variables using mutate. And then I only selected those variables along with the original time, just because we have 21 or so variables, remember, in our data frame, and printing out all of that was not going to fit. And I only for demonstrative purposes sampled the data and grabbed 5 observations, because otherwise our data was arranged in order of time, and then you would simply be seeing all the emails that came on January 1st. So now we can see actually that if an email's date timestamp indicates 2012/3/18, that's going to be, the date is going to be March 18. The day of the week turns out is Sunday, I think here, and then the month obviously is the 3rd month, March. So that's basically what this is doing. And we can imagine doing this to our data. We can imagine looking at other variables in our data frame and looking to see, might there be other useful pieces of information that we might want to extract in this way, or transform the existing variable in some other way to make the variables potentially more useful for our model. The thing is, if we were to use this approach of using mutate, we would have to do it once for our training data. And then when we build a model with the new variables that we have, the new features that we have engineered from our training data, we would then, before we can apply the model before we can do a prediction on our testing data, would have to apply the same changes to our testing data as well. So that feels like having to do something twice. And that you can imagine is error prone. So what we might want to do is actually take advantage of the fact that the Tidy Model suite of packages make this sort of thing a bit easier by providing specialized functions for it. So our modeling workflow, and earlier we gave a modeling workflow where we said we're going to split into training and testing, fit the models on the training data, and then evaluate them on the testing data. Now we're going to add another step here. We're going to create a recipe for feature engineering steps to be applied to the training data. So before we fit a model, we think critically about our data. We probably do a bunch of exploratory analysis to see, are there certain patterns that we might want to explore and extract? And then we create a recipe for feature engineering. In this case, our recipe will have, for example, a step that has something like take a look at the date time stamp, and using that, calculate which day of the week it is and which month it is. That'll be one of our steps in our recipe. Then we want to fit the model to the training data after these steps have been applied. And then using the model estimates from the training data, we want to predict outcomes for the testing data. And then ultimately, we want to evaluate the performance of the model on the test data. So our modeling workflow, we're revisiting it. We haven't changed it a lot. We've really added one more step earlier on that allows us to get a little bit more creative and get a little bit more critical about the data that's given to us. Simply receiving a data set and fitting a model to it as is rarely the best idea. We've talked about things like you may need to clean your data. Well, in this case, you may need to go a step further, and once you've cleaned the data, think about what it is that I'm trying to predict here, and what is this the best that I can do with the information that I have organized in these variables, or might I want to do something different? So how do we build these recipes? And once again, these recipes you can think about them as fancy mutate statements in a way where under the hood, we know what we're doing. We are transforming these variables in our training data set, but we're doing it in a way, using a new set of functions, doing it in a way where it's going to be easy to replicate this on the testing data as well. So we start this with the recipe function from the Tidy Model suite of packages. So we started with the recipe function. And whenever we build a recipe, I like using the _rec. So _rec for recipe in the naming. If you do this as we've talked about with _fit for models, if you follow this naming convention, it'll be easy when you go back to your code to see what each component is. And also, this is the convention that the Tidy Models documentation uses as well. So then when you read documentation or books that use Tidy Models, it's going to be easy to follow what's going on. It's just like using any other consistent notation in any mathematical setting as well. And we all know how frustrating it can be when notation is not consistent. So this is the naming convention is in a way trying to parody that. So we have a new recipe. And in our recipe, we start by setting up our formula. So that's spam tilde period, right? That's our formula. And then our data is our training data. So this is the data to use for cataloging names and types of variables. It's really not that we're applying this recipe to this data right this moment. We're actually just writing out the steps of our recipe. We're going to apply it later, but we need to specify some data here so that when we say things like we're going to make transformations in this way or convert things from one thing to another, R needs to be able to check for us that these things actually make sense. So if I take a look at the summary of this recipe so far, which basically has just about nothing in it, it tells me the variables that are going to be used as predictors and as the outcome. So we have 20 variables that are the predictors. That's all the variables other than spam in our data set. And then the last one here, you can see the role of the variable is outcome. So the roles your variables can take is outcome or predictor, or you can just say something else, like don't use them in the model at all. Keep them around. I think for that we use a role called ID. Maybe that'll come up in a future lesson that we go through. But generally the important roles are you have one outcome and a bunch of predictors. And we also can see here what type of variables we're working with. So one of them is a date. We have a bunch of numeric variables and some nominal variables, or in other words, factor variables. The first thing we're going to do is to remove certain variables. We talked in the previous video about why we might want to do this. So that was the from variable and the sent email variable, where we were having the separation problem with them, which was that some of the emails that none of the emails that didn't have a from address were not spam. And similarly, if you had sent somebody an email, they never sent you spam back. So we had these quadrants for which we had no data available. So we decided that we're not going to use these variables in our model. So instead of excluding them from our data set at this point with like a select statement, which we would have to replicate with the testing data, what we're doing instead is we're using a recipe step. So that's step_rm for remove, which basically says, once you start this recipe, the first thing you want to do is to remove the from and sent email variables. And actually, if we print this out, you can see that what it does is it basically deletes the terms from and sent email. And so it'll do it for our training set, and it'll do it for our testing set when time comes. The next thing we might want to do is to change or create new variables based off of time. So we showed this with the mutate statement earlier, but here we're doing something specific to dates. So we have another function called step date. And this is, here we could be looking at the time variable. And what we want to do, the features we want to extract are the date, day of week, and then also the month. Okay, so instead of writing this as a mutate statement, we're basically using these particular steps. If you're getting curious what sort of steps there are, a useful reference for this is actually the recipes package, which is part of Tidy Model. So if you go and take a look at the reference, you'll see the various step functions for doing imputation. So that would be for when you have missing data that you want to put something else in its place. For individual transformations, so for example, we could do a log transformation. For discretization, so turning a numerical variable to categorical. For creating dummy variables, which we'll talk about in a little bit, and for creating interactions or for normalizing your data. We also have particular options for multivariate transformations, which we're not going to get into in this course, but they basically build on what we're learning here as well. And so let's take a look at step date here. So we can take a look at the help here to see what are the types of things that we can do. So you can see that particular features, we can extract our day of week, month, or year of the variable. So let's go back to our code. Once I have created these features, so a new column basically for day of week and a new column for the month that the email was sent, I'm going to remove the time variable. I couldn't have done this in the earlier step because I needed that information to be able to build my features. But now that I have them, I'm not also going to use the timestamp additionally in my model for prediction. So I'm going to take that out. So we can see that here we're adding these new date features and then deleting the term time. We might also discretize numeric variables. Whether you choose to do that really depends on the nature of your data. In general, if you have numerical data, to turn it into categorical data might be, that's Dorian, might be losing information, which you may not want to do. You might actually want to capture all of the information that's available to you. But sometimes you might have data where you have lots of zeros and ones, for example, and then all the others are like you have extremely right skewed data. For example, for the CC variable in our data set, which is how many people were CC'd, lots of emails with zeros, a good chunk of emails with maybe ones, and then everything else was just like, you know, maybe there's one email with 30 CCs, but no other emails with that many CCs. And you might think about, ultimately, what we're trying to predict is the email spam or not? So in this case, does it really matter how many in the CC, or are we more interested in a range? You know, 0 might mean something, 1 might mean something maybe, but there's probably not a difference between a 20 and a 30. It just means many people in the CC. So I'll show you two ways of doing discretizing the numeric variables, and there are other ways that you can read through in the recipes package documentation as well. So we're going to use the step cut function for this, and cut is basically actually a function in R for taking a numerical data and cutting it into bins. And so that's why the name of this function is step cut. And it can take as many variables as you want. CC, attach, dollar are all variables from our data frame. And basically what we're saying here is that we want to break at 0 and then another break at 1. And then everything else basically will be like 1 and more. And then similarly for the variables inherit and password, we want some more breaks. So I'm interested in 0s and 1s to 5s and 5 to 10s and 10s to 20s. And then everything else we're saying, well, if the email says password in it more than 20 times, maybe it doesn't matter if it says it 30 times or 300 times at that point. So we're binning those together. So again, this is really, you can think about this as a case when statement on steroids. We do know how to create all of these transformed variables, but with the recipe steps, we're transforming them in a way that can be easily captured as part of our modeling workflow. So these two steps basically translate to we want to cut these numeric variables for the particular breaks that we identified. And then for all of our categorical variables, we want to convert them to we want to create dummy variables for them. So that's step dummy. And last week when we introduced dummy variables, we said, well, we don't necessarily have to do these by hand. If you're fitting a single model, R will simply do that for you. And that is correct. But you might be fitting various different models where sometimes that happens by default and sometimes where it doesn't. So as you're creating your recipe to prepare your data for modeling, you might as well at that point create the dummy step as well. So what we're saying here is that we want to create dummy variables for all of our nominal variables, so all of our categorical variables, except for the outcome. We don't need a dummy variable for the spam variable. It's not that we don't want a dummy variable for the spam variable, because the notion of a dummy variable really only makes sense in the context of predictors, not our outcome. And then finally, we want to remove zero variance variables. So this is in some ways a new idea, in some ways we've talked about this before. Remember in the previous video, we identified another variable to remove from our data sets, which was the Viagra variable, because we had no observations in our training data that had anything other than a 0 in the Viagra column. So all of those selected emails had 0 mentions of Viagra in them. And we hypothesized that that's probably because so few emails have this mention that it's actually the handful that there are happen to end in the testing data. And you can imagine why that is. These are emails from an inbox. So these have already been filtered probably through some sort of a spam filter at this point. And so maybe that was caught really, really easily. So zero variance variables are basically variables that contain only a single value, okay? So that would be like the Viagra variable that had all zeros down the column. we want to remove these variables. But earlier, in order to identify which one that was, we ended up doing a little bit of exploratory analysis. We looked at the skim output of our data set and finally realized that might be what's going on here. And that is a tedious process. And also note that we also don't get to look at our testing data, so we're only getting to look at our training data, but whatever steps we have, we want to be able to apply to both. So we want to have a way of removing these variables without us having to do the digging. And that is basically this recipe step, which is step_ZV for zero variance. So these are variables that contain only a single value. And we're basically saying among all of the predictors, if you catch such a thing, kick it out. We don't want them. So that basically will do a zero variance filter on all predictors. All right, so this is the recipe all in one place, basically. And what I'm doing is this is all the steps that we've been through. And we're basically adding these to creating a new object called email recipe, so email rec, and saving that. Now we're going to, based on this recipe, build our workflow. So we've used a workflow in a variety of ways, but here we're going to use it a little bit more formally. So remember that when we want to define our model, we start with our kind of model specification. So that's logistic regression. And then we set our engine. In this case, that's the GLM engine. So I can save that as this is the type of model I want to fit. Okay, that's our model specification email mod. And then what we're going to do is we're going to bring together that model object and the recipe that we had put together. So really, these are all steps we need to go through when doing modeling, but we're bringing these puzzle pieces together in a way that will be easy to replicate between our training and testing data. So workflows is a package that's part of the tidy models, but also in general, this notion of a workflow is that it brings together models and recipes so that they can be easily applied to both the training and the testing data. So we initiate a workflow with the workflow function, and then we add our model, that's the model we just defined, and then we add our recipe, which was the recipe that we outlined. And in this case, I've given you some justification for the steps that went into the recipe. Some are steps that you always need to do, like the dummy step and the zero variance variable steps. And some is more about getting creative with your data and exploring it. So don't take this to heart as like this is the best thing one can do in terms of feature engineering, but it's really a potpourri of the types of things you can do mixed in with a few things you definitely should be doing. So that was the recipe that we created, and we're going to add that onto our workflow as well. And again, just like with other tidyverse functions, we can kind of chain these together using the pipe operator. And so now what we have is a workflow, and that has a few components to it. It has a preprocessor recipe that we outlined, and we can see the steps of the recipe. If I had more steps, we would be seeing more things here. And then it has a model as well. So really the only thing it needs right now is a data to be applied to. So now we can fit our model to our training data. So we're saying here's the workflow, fit this to our training data. And we can take a look at the outcome of this. I've printed it out all in one place. We ended up with 31 kind of estimates. One of them is the intercept, but we have more than what we had started with in terms of the number of variables. And that's because for some of our numerical variables, we have discretized them. So now they're categorical variables with multiple levels. So we have a dummy variable for each and every one of those, -1. And also in some cases, we have removed some variables as well. So that's how we ended up with the 31. Let's take a brief look at the coefficient estimate. So I'm only going to focus on the estimate column here. Re-subject. Okay, so this is if your email has re in the subject. We had said earlier that our hunch was that it would be less likely to be spam. And in fact, in our training data, we saw that that was the case. And here now we're also seeing that we're ending up with a negative slope estimate for that. So in fact, if the email has re in the subject, it's less likely to be spam. We can also take a look at how the days of the week compare. So Sunday is our baseline level. It looks like the slope coefficient for Monday is negative, so less likely than Sunday. So emails coming on a Monday are less likely than those coming on a Sunday to be spam. And remember, all else held constant. So whenever we're doing our interpretations for multiple regression models, we're looking at that coefficient one at a time and then keeping everything else constant. So we can go through and take a look to see, if these values make sense. But before we get into really the nitty-gritty of interpreting each and every single one of these, we probably want to check to see, is this model good? Does it have good predictive performance? Should I really spend more time on it? So now what we can do is we can make predictions for our testing data. So what we're going to use here is, again, the predict function. So our model was email fit, that we fit based on using our training data and the workflow that we had outlined. So that workflow information is still captured in this fit object. And then we want to do a prediction with our test data, and we want our probabilities out. And then I'm just going to bind the columns from my test data as well. So I have everything in one place, my raw test data, but then at the beginning, I have two new columns that are the probabilities that the model predicts that the email is spam, and also the probability that the model predicts the email, is not spam and spam. Okay. So here's our overall output, and we can see, for example, in the first row that the probability that the email is not spam is 0.96, and in fact we are seeing that the email was not spam. So these first few rows look like the model is doing the right thing. We can also take a look at our ROC curve again. So I'm doing exactly the same thing as I did in the previous video to get these ROC curves in terms of my code. And really my workflow at this point is the same. It's really at the beginning we added this recipe step, which was different for our feature engineering. So we are seeing that our ROC curve is, taking that shape that we would like to see away from the diagonal. And we can take a look at a numerical value. And in fact, it looks like we were able to do just a hair better than what we had done before in terms of the area under the curve. Again, that number on its own is not really meaningful, but it can be useful to compare to other models. So we can imagine making many different models and actually plotting their ROC curves. That being said, we only get to do this so many times. So we really want to try to do better in terms of our predictive power with our training data, and then finally apply it to our testing data. Because now that we know how this turned out, now that we've gotten a look at our testing data, we really don't get to go back and fix things up based on what we learned here. All right, so as a last point, let's talk a little bit about making decisions. So suppose that we decide to label an email as spam if the model predicts the probability of spam to be more than 0.5. If I was to do this, and we can take a look at my code here, what I've done is I've taken a look at the probability that the model predicts the email is spam, and I've used a cutoff value for 0.5. So if it's greater than the cutoff value, then I'm going to say email is labeled spam, and otherwise email is not labeled spam. And then to keep the words the same as an earlier video, we've seen one of these tables renaming the spam variable as email is spam and email is not spam. So over here, for example, of the 77 spam emails that were in our testing data, 10 of them are labeled spam and 67 of them are not labeled spam. So those actually will filter through that 67 emails you get to see in your email. And you only manage to capture 4. And then of the emails that are not spam, 4 of them went to your spam box. And you might decide, that's not that bad out of 707, or you might decide I really don't want real emails to end up in my spam folder. We could change that probability to 0.25. So here, if the model predicts a probability of 0.25 or more, or greater than 0.25, we're labeling the email as spam. So in this case, of the 77 emails, 37 of them are labeled spam and 40 not. But now 48 of your real emails ended up in your spam box. And that might be a really high number out of 700 something. If we were to increase the cutoff probability to 0.75, now only 5 of your emails are labeled, of real spam emails are labeled spam. So you're getting a lot of spam actually filter through into your inbox. 72 of them, but you're doing really well in terms of not accidentally labeling emails spam. So these probabilities will probably vary based on your comfort level with your emails going into your spam box or not. And if you are actually building a spam filter like you are Gmail and trying to do this, in that case, you probably try to make a decision that you think is the one that works for your community.